All right, so what we're looking at now is putting everything together, and we're looking at sine and cosine law word problems. And as I've mentioned, the hardest part about word problems, you got to draw the picture yourself, given the words, and that's requires you got to interpret the question right and be able to draw the picture right. Now, again, because we're dealing with the cosine and cosine laws, plural. Here's the three formulas that we looked at. We have the sine law, which is you can use it to solve angles and sides. We have on our left here the cosine law to solve for a side. And on our right, we have the the cosine law to solve for an angle. Now, again, when we use the cosine law for finding a side, it's a situation where you have side, angle, side. And the other situation is for using the cosine law, because there is only two. That's the best part about it. Everything else is the sine law, is when you have all three sides, which is called SSS, side, side, side. All right, so if we don't have these two situations, then we're over to the sine law. So that's pretty much how I approach these problems, is I try to use the cosine law. There's two situations. Outside that, then we go to the sine law. Has to be. All right, so we start off with example number 1. Your neighbor has a triangular lot in which the backyard meets at a point. One property line measured from the street to the back point measures 80 meters, while the other property line connecting the street to the back point measures 65 meters. If both property lines make a 70-degree angle with the street, how wide is the property at the front of the house where the street is? Okay. As I've mentioned before, with word problems, I always read it once. And then the second time, I try to draw my diagram. The third time I read it, I want to make sure my diagram's all right. So the first thing here is we've got a triangular lot in which the backyard meets at a point. All right. So we're looking at something like this. No, that's terrible. Let's draw a good picture here. Oh, it's a little better. All right. So here's our triangular property. All right. Now, second sentence here. One property line measured from the street. So this is the street right here. To the back point measures 80 meters. Okay. So from this point to the back point. So this is, I'm going to write this in here. Let's get some labels on here. So back. All right. So there's the back point. Or the back, and over here is, down here is our street. And my drawing's not the best, but that's why it's a nice little sketch. All right, so let's get to this question again. One property line measured from the street to the back point measures 80 meters. All right, so just because it's a diagram, I'll label that 80. While the other property line connecting the street to the back point measures 65 meters. All right. If both property lines make an angle of 70 degrees with the street, how wide is the property at the front of the house, or front of the house where the street is? Okay, so the angles, property lines. There's our two property lines, and they make a 70-degree angle with the street. So there's our 70 degrees, and they both do. Okay, and we want to know how wide is the property at the front of the house. So there's our X right there. Okay, so first off, I got to label this diagram A, B's, and C's. Now, if I'm trying to find X, I'm going to say this is point A right there. And I guess this will be point B, and this will be point C. Now, this is where I need to decide which formula I'm going to end up using. All right. Well, I can write down my variables. That's also a thing I could do too. Why don't I do that first before I get to the formulas? So again, let's see here. Angle A. Yeah, I don't know it. B, I do know it. 70. C, I do know is 70. All right. Now my sides. Side A. That's what we're looking for. That's X. Side B, again, across from angle B is 65. And then side C which is what do we got here? It's also 60 or it's 80. All right. Now, we're trying to find x, but see, I don't have I'm looking for side angle side. So I got 80, 70, but I'm missing x. So there I got no side angle side there. I go over to the other side here, 65 angle, again missing the side. And I don't have all three sides either. So I can't use SAS, side angle side, and I can't use side side side. So it's not a cosine law. So that's telling me right away I'm going to be using the sine law here. All right, so let's take see if I can copy that. Yeah, there we go. Control C. And so that's the formula I'm going to be using here. Okay. Now, it's the parts. Remember this formula. We have to use two out of the three parts. Now, I have to use the A part because I'm finding X. And then I can use whatever parts that I know everything. And in fact, this time, I know both the B and the C part. So I'm going to go with the A and B part just because they're beside each other. Now, there is a problem here, is that I need angle A to use the A part as well. And this is something we went through, is that all the angles inside of a triangle add up to 180. So I can find angle A because there's 180 degrees inside that triangle, but I take away 70, and then I take away the other 70, and the leftovers will be my angle A. And if I take 180 and I subtract 70 and then 70 again, I got 40. So put a little 40 in there. All right, so I'm going to use the A and the B part. All right, so now it's time to substitute in. So on the top, I'm going to have sine 40 equals, and on the other top, I'm going to have what's angle B, 70. So sine 70. The denominators, side A, that's what we're trying to find out here. That's X. And side B here is 65. All right. So now I can simplify this first because, again, I don't like dealing with sine 40s. I saw a couple of you before like doing that, but I don't. I like numbers, so I type sine 40 in. Oops. Sine 40. And I get 0.64. And I equal sine 70, which I get 0.94. All right. Now, again, the denominators there are x, and the other denominator is 65. Well, we've had this many times already in this course. We have a fraction equaling a fraction. So I'm going to cross multiply. All right, so I'm going to end up with, let's see here, 0.94x is equal to 0.64 times 65. All right, so I've got my 0.94x. Can't do anything with that, but I can simplify that 0.64 times 65, and I get 41.6. All right, still want to get x by itself here, and that 0.94 is attached, so the only way to get rid of it is to divide it off. So I'm going to divide this side by 0.94. What I do to one side, I got to do to the other. And so x is going to be, whatever, 41.6 divided by 0.94. And I ended up with 44 point, again, going to two decimal places, 26 meters. There we go. All right. So again, drawing the picture, figuring out what we got, and then we got to figure out what formula we're going to use, which is always tough. All right, let's try another one here. So it says, example 2, on a 520 meter hole. That's how they measure holes sometimes in Europe, not in the US and Canada. It's always yards, but we're Canadian, so we'll go with meters. A golfer's tee shot goes 175 meters. and is 20 degrees right of the direct path to the flag. Okay. The second shot goes directly into the hole. How far did the golfer hit the second shot? Okay, so I'm going to try to draw this situation again. And so we've got a golf hole here. And so there's a straight shot. But that's not what happens for this person. They miss it to the right. All right, so I'll draw it like that. And then the next one goes straight into the hole. All right, so I'm going to label this a little bit here. So here's our flag, or the hole, I should say. And here's our start down here. Now, what else we got here? So it's a 520-meter hole. So that's telling me this distance from the start to the hole here is 520 meters. All right, the first shot here went off to the right, 20 degrees actually. So I'll throw a 20 in here. And the shot was 175 meters. Okay. And shot goes directly into the hole. So I've done that. How far did the golfer hit a second shot? So there's our first shot's 175. This is the second shot, which would be X. All right. Now we want to solve for X. So let's see here. What do I got in terms of my information? Again, I always look for the cosine law to see if I can use it because there's only two situations. All the other situations are sine law. But you can see here, I've got side, angle, side. I do have the SAS. So I am going to use the cosine law. All right, so let's copy that guy. Let's go over. Whoops. So there's because we're trying to find a side. So I grab my side formula here. All right, there's our formula. Now to label my diagram, because I don't have any A, B's, and C's on here, right? So because I'm trying to find this side, I'll go across here, and I'm going to make that start here, side A. And I don't know, I guess the hole would be side B, or point B, and where the second shot was taken from, side C, or corner C, I should say. All right, labeling my side. So X is actually my side A. Across from angle B, there's side B. And across from side C, or angle C, I should say, is side C. All right, there we go. So now I'm going to substitute in to my formula. So instead of A squared, I have an X. So we have an X squared. B squared, I'm going to have 175 squared. C squared, I'm going to have 520 squared. And then I got this minus 2 times B, and B was 175, times side C, which was 520. All right, and then times cosine of angle A. Angle A, we've got, there it is, are my 20 degrees. All right, so now to solve, I just have to use Bedmas. So I have X squared. So I'm going to do my exponents first. All right, so let's see here. 175 squared, 175 times 175. I get 30625. All right, plus 520 squared. It's going to be an even bigger number. And I get 2,700, or 270,000, I should say, 400. All right, then I got minus 2 times 175 times 520. Now that cos 20, that's a number. So I like I said, I like numbers. So let's get that down as a number, and I'm getting 0.94. All right, so continuing to solve. But again, I got to follow Bedmas, so I got to do all this multiplying over here. This is always the step where I see students struggle with the most. It's just following Bedmas. All right, so I'm not going to do anything with that 30,625 just yet. And same thing with this 270,400. But I am going to figure out this those four numbers multiplied. So I got 2 times 175 times 520 times that 0.94. And we end up with 171,080. All right. A couple more steps. Again, following the Pythagorean, or not the Pythagorean theorem, bad miss. Put my numbers together. All right. And so let's see here. Plus 270. Let's put these numbers together. And I end up with, let's see here. My number is 129,945. All right. And then the last step here is I got to get rid of that little 2 because I'm solving for x. So I have to take the square root. Only way to make that happen. And what I do to one side, I've got to do to the other. And now the square root of that 129,945. It's 360 point, again, going to 2 decimal places, 48. And it is in meters, which in real life is probably a little unrealistic. I think that's like a 400-yard shot, somewhere in there, in that neighborhood. But it went in the hole. All right. We got one more here. Let's see here. Example 3. A lighthouse is able to shine its light so that 2 boats, A and B, are just visible. Boat A and B are 7 kilometers apart, and the lighthouse is 5.7 kilometers from boat A and 6 kilometers from boat B. What is the angle of spread of the light coming from the lighthouse? All right, so we got a lighthouse and 2 boats. Okay, so again, I got to draw that diagram here. So let's see here. We go with a lighthouse right there, and then we're going to have a couple of boats. So this lighthouse shines a light, and we see 2 boats. Okay, and might as well connect them because we're going to, well, let's see here. We'll throw that in here first. So I'll say that's boat A right here. I guess that's going to be side A, possibly. See, might be easier to label it. And this is boat B. All right. And again, we're dealing with triangles, so I'm going to connect them. All right. Now to label this thing. All right, so let's go back here. Boat A and B are 7 kilometers apart. So there's a 7 there, kilometers. And the lighthouse is 5.7 kilometers from boat A. Okay, 5.7 here. And 6 kilometers from B. That's over here then. What is the angle of spread coming from the lighthouse? What's my angle here? All right. And since I got boat A and boat B, I might as well call to lighthouse here point C. All right. So again, do I have side, angle, side? Well, I don't even have any angles. So there's no chance of me having side, angle, side. Because again, I'm looking just to use the cosine law. If not, I got to use the sine law. But I do have SSS. I have side, 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 which does mean I'm going to use the cosine law. But I'm going to use the cosine law to find an angle. So I'm going to grab my formula there. Now I'm looking for angle C here. So I'm going to have to rearrange my formula again. And so this is where I'm going to switch A's and C's because I'm finding angle C. All right, so I have cosine of angle C. Because again, I'm switching A's and C's, leaving B's alone. So then I got a B squared. Instead of a plus C squared, I'm going to have a plus A squared. And instead of a minus A squared, I'm going to have a minus C squared. And then down the bottom here, I got 2BC. So it's going to be 2BA. Again, not touching B's, but switching A's and C's. All right, got my formula. Now to figure out which side's which, again, across from angle A, is side A. Across from angle B is side B. And of course, across from angle C is side C. All right. Now I'm going to substitute in to my formula here. All right. So I don't need the words anymore, which is great because I am not a big fan of English. That's why I'm a math teacher. All right. So we got cosine of angle C is equal to B squared. What do we got here? 5.7 squared. All right. Plus A squared. A is 6. So we got a 6 squared. I just put that 5.7 in brackets because it's a decimal. That's all. Minus C squared, which is going to be a 7 squared then. And then down the bottom here, we got 2 times B, which is that 5.7. And then times my A, which is 6. All right. So for this formula, I got to simplify the top, simplify the bottom. All right. So, and then I can figure out what we got here. So let's see here. We got cos angle C is equal to, let me see here, 5.7 squared. I get to 2 decimal places, 32.49. All right, plus, well, I know 6 squared is 36, minus 7 squared, 7 times 7 is 49. All right, then in my denominator, again, I got to figure it out. It's not as hard because it's just multiplying 3 numbers. So 2 times 5.7 times 6. And I get 68.4. All right. Ooh. All right, so again, I still got to simplify my numerator. So I got the cos of angle C. Let's see, put those numbers together. 32.49 plus 36, but yet minus 49. And I end up with 19.49. And again, my denominator here is 68.4. Things are getting easier. We're going the right way. It's looking simpler, getting simpler. All right. Then I'm going to, of course, that fraction there, going to make it a number because all a fraction is divided by questions not done yet. So I take my 19.49, I divide it by 68.4, and I get 0. To 2 decimal places, 28. All right. Now our last step. We have the decimal. We want the angle. So that's where we're going to have to use cos inverse. And so in my calculator, I'm going to find my big angle C here. Whoops. Put writing. So I cos inverse 0.28. And to 2 decimal places, I get the angle here for the lighthouse of 73.44 degrees, which is good. You want a lighthouse with a large spread so you can see the boats and they can see you. And there we go. So again, the first thing I'm looking for is to use the cosine law because there's only 2 situations. Side angle side for the one formula, side for the other. All the other situations that there is are you use the sine law. But again, the tough thing with with solving word problems is actually drawing the pictures.